Hi everyone, welcome to Graphing Quadratics in Vertex form part 2. In this lesson we're going to graph y is equal to negative 0.5 x squared plus 2x minus 1, which is in standard form, and I'm going to show you how to rewrite it in vertex form and then graph it using the parameters a, h, and k. So this is kind of like an algorithmic process. You're going to follow the same procedure every time you go through this, and it should work on every quadratic function that's written in standard form. So standard form is when you have a quadratic equation written in the form y is equal to ax squared plus bx plus c, and we're trying to rewrite it in the form y is equal to a times x minus h squared plus k, so that it's easier to graph. So let's start with question B. Well, we have negative 0.5 x squared plus 2x minus 1. And if you look at the form of if you look at the form of vertex form, you have to somehow get an a coefficient out front. And inside of these brackets here, there's no coefficient on x. So there's no coefficient multiplying x inside of these this square bracket, or inside of this binomial that's being squared. So the first thing that we're going to do is we're going to common factor. We're going to common factor whatever the a coefficient is out of the first two terms. Okay. So you'll see why I'm doing this in a second. So we're going to divide x squared by negative 0.5, which is just x squared. We're going to divide positive 2x by negative 0.5, which is negative 4x. And then the constant term, so this right here is called the constant term. We're just going to leave the constant term outside of the bracket. So we'll leave that minus 1 outside of the bracket. So next is we'll take half of whatever this coefficient on x is, this coefficient on this linear term, which is negative 4. We're going to take half of that, we're going to square it, and then we're going to add it and subtract it. So we'll get, whoops, something's going weird with my tablet here, sorry guys. Okay, we're better now. So let's take negative 0.5 x squared. We're going to have negative 4, which is negative 2, square it, which is 4, and we're going to add and subtract 4. So we'll get x squared minus 4x plus 4 minus 4 minus 1. Now we haven't changed the value of this expression because we've added 4, but then we've also subtracted it as well. So all that we've done is we've just added 0, which is an identity operation for addition. So then we have negative 0.5, and what we'll do is we'll take essentially what we've done is using these three terms, we've created a perfect square. So what we can do is we can take these three terms and we can group them together like that, and they factor into a perfect square. Those three terms factor into x minus 2 squared. So we have x minus 2 squared, and then we have minus 4 at the end. And then I'm using square brackets just to kind of group the x minus 2 squared together, which came from these three terms. And then at the end we still have minus 1. So lastly, using the distributive property, I can distribute negative 0.5 into the brackets here. So if I multiply negative 4 by negative 0.5, I get positive 2. If I multiply x minus 2 squared by negative 0.5, I can just leave that written out front as my a coefficient. So I've got 0.5 times x minus 2 squared, and then I'll have plus 2 minus 1. This is all that I'm doing is I'm just distributing negative 0.5 into the square brackets. And I'm not going to expand x minus 2 squared. So I've got negative 0.5 times negative 4, which is positive 2. Positive 2 minus 1 is positive 1. So now this is written in vertex form, and we can use vertex form to graph this equation. So let's go ahead and do that. Well, remember that we can first off figure out what the vertex of this equation is. The vertex of this quadratic is going to be 2 comma positive 1. So my vertex is 2 comma 1. So I'm going to plot that on this grid that I've got over here. 2 comma 1. Let's see here. So let's go over 2, up 1. That's my vertex. The next thing that I'm going to do is recall from the last lesson that using the a coefficient, we can figure out what the step function is by multiplying 1, 3, 5, 7, 9, 11 by 13, and etc. by whatever this a coefficient is. So here our a coefficient is negative 0.5. So we'll get a step pattern of negative 0.5. Because 1 times negative 0.5 is negative 0.5. 3 times negative 0.5 is negative 1.5. 5 times negative 0.5 is negative 2.5. And we can just continue that pattern. So if we follow that pattern, we're going to start at the vertex. We're going to go over 1, down 0.5, put a point there. Over 1, down 1.5, put a point there. Over 1, down 2.5, so 2.5 is right here. And then over 1, down, next point would be 7 times negative 0.5, which is 3.5. So we'll go over 1, down a half, down 1.5, 2.5, 3.5. So that's the last point that we can fit on the grid. We can reflect all of these points about the axis of symmetry, which is the vertical line drawn through my vertex. And that'll give us the points for the left half of the parabola. And lastly, we just draw a smooth curve through our parabola. And since I don't have a steady hand, I struggle with this, but just do the best that you can to make it a smooth curve. So this parabola is y is equal to negative 0.5 x squared plus 2x minus 1. So that concludes that example. Next, let's move on to y is equal to 3x squared plus 6x plus 1. So remember the procedure. First step, common factor whatever this a coefficient is out of the first two terms. If you do that, you get 3 times x squared plus 2x plus 1. All that I've done is I've divided this term by 3 and I've divided this term by 3. The next step is to take whatever this coefficient is inside of this bracket beside the linear term, divide it by 2, square it, and add it and subtract it. Because we're trying to create a perfect square here. Or a perfect square trinomial, rather. So half of 2 is 1. 1 squared is just 1. So we're just going to add 1 and subtract 1. So we get x squared plus 2x. And this is where we add 1 and subtract 1. And remember that the constant term always stays outside of the bracket. So a plus 1 outside of the bracket. Next, again, we've created a perfect square trinomial here. So we're going to factor that into x plus, this factors into x plus 1 squared. So we've got 3 times x plus 1 bracket squared minus 1 plus 1. So lastly, to write this in vertex form, all that we're going to do is we're going to distribute 3 to this term right here and to this term to essentially get rid of these outer brackets. So we're using the distributive property. So we get 3 times bracket x plus 1 squared plus 3 times negative 1. 3 times negative 1 is negative 3. After we distribute, we essentially get rid of these outer brackets. So we'll have negative 3 plus 1. Negative 3 plus 1 is minus 2. So in vertex form, we can rewrite this as 3 times x plus 1 squared minus 2. Now we can go ahead and we can figure out what the vertex is. So the vertex of this parabola, let's use green for this. I like the color green. The vertex of this parabola is minus 1 comma negative 2. Because remember that the x-coordinate of the vertex is always the opposite of whatever this sign is. It's always the opposite value of whatever this number is. So since this is positive 1, our x value is going to be negative 1, and the k value is negative 2, so the y value of our vertex is negative 2. We also need to figure out what the step pattern is going to be. So we're going to take the step pattern of y is equal to x squared, which is 1, 3, 5, 7, and 9, etc. And we're going to multiply this step pattern by whatever the a coefficient is, which is 3. So we're going to multiply this entire sequence of numbers by 3. So 3 times 1 is 3, 3 times 3 is 9, 3 times 5 is 15, 3 times 7 is 21, and 3 times 9 is 27. Oh yeah, okay, we're good. Okay, so this is our step pattern. We're not going to be able to fit all of the points that I've got here on the grid, but as a rule of thumb, you have to fit at least 3 points on a graph in order to graph a parabola. So in order to graph any parabola, you need at least 3 points. So let's start off by plotting the vertex. Well, the vertex is located at 1 comma negative 2, so let's put a point there. 1 comma, negative 1 comma negative 2. Negative 1 comma negative 2 is right here. Next, let's follow the step pattern. So we're going to go over 1 up 3 from the vertex, and then over 1 up 9, which is completely off the grid. So we can really only fit 3 points on our graph. And that's all that we need for now. That's okay. We include arrows at the end of our function to denote that the parabola keeps going. Let me redraw that just because that one is really awful. Again, I don't really have a steady hand, so bear with me. That's why I'm not an art teacher. Okay, that's a little bit better. So that's the graph of y is equal to 3x squared plus 6x plus 1. So now that you've seen how to graph parabolas in vertex form, in the next video we'll look at how to graph parabolas using the x-intercepts. That concludes this video, and we'll see you in the next lesson.